Hello, everyone. I'm Stephanie Boozer with CUGC HQ. Welcome to today's user share webinar. Got a lot of great stuff coming at you today. I know that we've had a lot of interest around this topic, so I'm not going to take up too much of your time, but I did want to go over a couple of our upcoming CUGC events. I've put a link in the chat for you. It's to our events calendar, so you can get to all of these things through that. But as you can see, we've got some local meetings going on this week, West Michigan and Detroit and Chicago. And fun fact about those meetings, they're all on the same day. And Tim Mangan, a CTP fellow, is speaking at both meetings. So the cool thing about being in the virtual space is that people like Tim can travel around really quickly. So definitely check out our calendar. We've got lots of great stuff coming up. Got 2 webinars next week, as you can see, and we've got our CUGC XL Northeast coming up in June. Lots of great stuff for you, so check all that out. All right, I'm sure you know why you're here today, so we're going to get right into it, and I'm going to let you know that we are recording today's session. You'll get a link to the recording, and it's going to come to you in an email from GoToWebinar, so be on the lookout for that. It should get to you tomorrow. Please do type in your questions in the chat question box anytime that you have them. We'll try to get to as many as we can today. I think we're going to save the bulk of them for the end of the presentation just because we want to keep things moving, but definitely type them in as you have them. Also, towards the end, I'll have a link in the chat for you to a survey. It's short and anonymous and for our use only. And there's a question in there for you to let me know if there are any other topics of interest for more webinars like this one. There's an unsponsored user share content like this. We always like to get a sense of what you're dying to know about. So definitely fill that out for us. All right, so I'm so happy to welcome to our webinar stage Patrick Vandenborn. He is a CTP, and Rick Stijnman. He is a solutions engineer and architect. You see their Twitter handles there on the screen, so screenshot those. Also have with us today Jake Walsh. He is a Citrix technology advocate, and he will be keeping an eye on all your questions. So hello, Patrick, Rick, and Jake. Thanks for being here today.
Thanks for having us.
Thank you, Steph.
All right, so Patrick, I'm going to send you the screen right now. And there it comes. And I'm going to disappear and I'll be back later.
Okay, so do you guys see my screen? Oh, and now I'm seeing only the, okay. Do you see my screen? Okay. Welcome to our session about deploying Windows 10 multi-user with Azure DevOps, Terraform and Packer. And Rick and I started our DevOps journey, I think about 9 months ago, Rick?
Yeah, and, 9 months ago.
Yeah, and as a traditional sysadmins, yeah, it was a steep learning curve for us, and we thought like, hey, maybe it's a good idea to share our experiences, what we've learned about Azure DevOps, the thinking of DevOps, Terraform, and Packer. So a little bit of an introduction, like Stephanie already told in the intro. I'm a Citrix technology professional. And I'm also a member of Team Remote Graphic Experts. So that's where all the GPU geeks are coming together about how to deliver the best user experience with HDX. I'm also a member of Go AUC, and for Go AUC, I'm doing some researches and mostly performance based on Azure. And I'm also doing the lab redeployment with Terraform and Packer these days via Azure DevOps pipelines. If you want to read my blog, you can just go to my blog. And if you want to connect with me on LinkedIn or Twitter, just this is the information.
Hi, and my name is Rick Stijnman. I'm working for a Dutch bank. You see my handles here in the screen. Yeah, that's basically it for me.
Okay. So some kind of agenda for today. So at first, we will tell you about our journey to Azure DevOps SCRUM approach. Then we will give you some context about our project. Why are we doing our Windows 10 multi-user session deployment via Azure DevOps pipelines? Then we will get you into the world of infrastructure as code with Terraform. And at the end of the session, image as code with Packer. And there will be some room for questions. So we want to try to give a high overview of all these topics because yeah, every topic itself is a session, but we want to give you an idea of this new world.
Yeah, so and let's start with our DevOps journey. So Patrick already mentioned we started in 2019 with our Citrix Cloud project, and it was created after a POC. But back in the days before 2019, we were a little bit of a project-minded organization with a waterfall approach, bringing cards from left to right on the board with a daily stand-up. Basically a bit of Kanban, what we're doing. And in 2019, we basically started with the DevOps teams within our organization, and that that process is still ongoing to improve that. But the start was bringing ops and dev together, but that really didn't work out that well because people were just throwing stuff over the fence. From that's an ops job and ops is doing that, and engineering, please engineer something for us. So in 2020, we as an organization introduced really the agile way of working, and then we introduced the product owners and Scrum masters, basically adopting the Scrum framework. The teams also, because we did it across the whole organization, the teams had a shared backlog. So the product owner is responsible for his backlog with all the items and cards on it, makes the priority, and the Scrum Master is maintaining that Scrum process to make sure that everything goes in place. And we already seen there some improvement, and engineers doing some ops work and ops guys doing some engineering work. And 2021 really started for, especially for Patrick and myself, where we really did the real DevOps, where it all came together. And that's why I'd like to take you through this journey, why we did it. So if we go to the next slide, Patrick.
Yeah.
Yeah, I didn't do the pen, so sorry about that.
Yeah, but I can't see your camera, mate. So.
Yeah. Oh, okay. Oh, sorry about it, but okay, I'll just ask. Can you click, please, for me?
Yeah.
So in a normal way, when we ask an engineer to, for example, to build something within our organization, and we had this project-minded way of working, he started in dev and built and clicked the whole configuration together, mostly GUI based. And then if you can click, Patrick, thanks. Then you go to the test environment and does exactly the same thing all over again. And then he goes to the production environment. If you can click, yeah, great. Then he had to do it all over again and brought it to production. And basically, what you see is that this person, how good as he is with the best intentions, had to do his work repeatedly and had to do it manually, sometimes even they scripted, but still there was no standard way of delivering the same configuration through the environments. So this is how where we were coming from. And if you can click, Patrick. Yeah, so the DevOps way is different, and people with an developer approach building software are familiar with it, but we as infrastructure guys aren't. So what we do with this same example, we start creating the configuration in an Azure repository. So if you can click, Patrick. So in the repository, the code is defined, and the different environments, the parameters are just adjusted for the environments. And then if you can click, please. Then Azure Pipeline launches the configuration with the, you were doing great, to the dev environment, and also you apply a test plan. And then the same configuration can go across the environments, but just with different parameters. and then the pipeline just makes sure that it talks to the environments. So that sounds very logical, but we weren't doing that for years, while our friends from software engineering and developers were doing it like this already. So if you can click. Yeah, so this whole new way of working, so basically what we say to each other, when Patrick and I have to do something, then we say we do everything as code. We don't do it manually. It's fine to do it once to see how it works, but then you code it. So we go from a GUI interface to an everything as code, and Packer and Terraform are a result, and just in my eyes, just tools achieving this. So why are we doing this DevOps way? And then we need to click, so there is a fast delivery of configuration that by using Azure DevOps, and of course there are different DevOps tools around that, but we as an organization, fully Microsoft, are using Azure DevOps. There is a fast delivery of the configuration through those environments, and the quality control of the configuration, basically you want to keep them equal as possible. And it gives, once you have written that configuration, you don't have to write it again. So there's less repeated work, and that's why it also results in less unforeseen issues, less user calls, because you already tested it throughout those stages. But it does have impact. People who do traditional IT have to change. They have to change from let's call it legacy sysadmins to developers. It's fully agile, and it's really focused on the process to make sure that the process is working, instead of doing ad hoc work. But it also has a downside. It is, like Patrick said, a steep learning curve. So you do make mistakes. But that's a good thing in my eyes, from even with an agile approach. It's by making those mistakes, you can learn and improve. And the hardest mistake you can do is that you wrote something wrong and then you throw it away. You start over again. That's one of the things what can happen. But that's basically the way we're doing it now. And basically, if people, basically the one question is, why should I go to DevOps way now? Basically, in short, shorter time to market, less issues, everything tested out. So you can click, Patrick.
Yeah, but Rick, I think in this sprint we also have some advantage now that we started to create our code from our Australian region, and with a less effort, we can just use it as Lego blocks and apply it within days to our EU region, which we are now spinning up. So that's,
exactly.
For me, it was last week like, wow, this is awesome. Like we spent that much time putting everything in the code, and now we're just deploying EU within days. That was awesome.
It's the investment, the initial investment that's high. And then you, like you said, you make it Lego blocks. And then you make it smart, and then you have the benefits. And also with those tools, we chosen for Terraform and Packer, for example. But I've asked you before your holiday to spin up a test environment for something. I believe you put in 15 minutes, you had it up and running.
That's awesome.
I do remember. That's good. Go to the next slide, because I do remember. I love this story to tell. You first want to show all the you have to click to see all the words. Branch, repository, commit, release, all those pipelines. All those things were new to me. CI/CD, push, fetch, pull, whatever, cherry picking. I remember that we as an organization have a cloud competence center, basically overseeing all our public cloud projects. And I had to deploy a VNet somewhere in Azure, and it had to connect it via our express route. And then, I had to request that. And I was sent off to somebody's desk, and I was at this cubicle. And I said, okay, mate, can I have this network and over express route? He said, I already give you the information. Just go to our repository, fork it, and put in your parameters and launch it through a pipeline. I said, I'm working for 15 years in IT now. And what you just said, are you sick? Do you need help? Or what's going on? Yeah, and then I was thinking, okay, I missed something here. And he really took the time to explain everything to me. But basically what they did is that they put everything already in code. I just have to fill in the blanks, run it, and it was deployed in my subscription. And that was really an eye-opener for me, like everything can be a service, everything can go as code. So, next slide.
Cool.
Our DevOps journey started, and I'll give it now to Patrick. So,
yeah, I like the NASA approach here. The DevOps journey started, and it was a really a big journey. So first, I want to give you some context about our project deploying Windows 10 multi-user on via Azure DevOps pipelines on Azure. So we basically, in our project, we defined three different small projects. The one is infrastructure as code, and we are using the tool HashiCorp Terraform for it. We're doing image as code, and that's basically how we build our golden images. So we therefore we use HashiCorp Packer, and we also do, as we call it, desktop as code. So we define everything in Citrix PowerShell, SDK, APIs, and the automated configuration templates. So if you look at the infrastructure as code, we are deploying, for example, our Citrix Cloud connectors, federated authentication services, key vaults, our networking, and all the lower parts of the Azure module on our platforms. And as a start, we do this on Azure. If we look at image as code, we have to deploy our images, for example, on VMware vSphere, hosting our published applications from Windows Server 2019. We have some we are going to host an Office virtual desktop with Windows 10 multi-session in Azure. So we're building an image with Packer for that. And when we are 4 or 5 iterations away, we also want to deploy our Windows 10 single sessions on Amazon AWS. And if you look what we're doing with desktop as code, so we're trying to do the whole cloud config. So we save the cloud config in our Azure repository, so we can redeploy that again, for example, between our different Citrix cloud tenants. And we're doing the Citrix virtual apps and desktop services, resource locations, identity and access management, but also the zones, machine catalogs, by automatically update an image which is delivered from HashiCorp Packer, for example. And for those who want to do WVD as code, you can also use HashiCorp Terraform, and there's I will show that later in the session. There is an option to use the desktop virtualization part to make, for example, a host pool, which is an equivalent for a machine catalog or a delivery group. So for 2 weeks ago, I was in a conversation with Citrix, and one guy surprises me. So I want to give you a tip in the session, and it's called the Citrix Automated Configuration Tool. And if you don't know what it is, it's a tool, and you can now back up your configuration. So it will be backupped in a YAML format, and you can apply those YAML files to your Citrix Cloud configuration. And basically, you can also use this as a desired state configuration. So here's a screenshot of me doing a what if for applying a YAML file with my Citrix policies, and it will tells me like, hey, the unfiltered policy would be updated, and all those other policies will be added. So if you want to dig in of a desired state configuration tool of Citrix, you can try the Citrix automated configuration tool. It's really, really awesome, and it surprises me when I played around with it for 2 weeks ago. So if you look at our whole environment, we have to deploy an environment for about 4,500 users, and our goal is everything as code. And due to compliancy and auditing policies, it's mandatory to deploy everything via Azure DevOps pipelines, since everything is locked over there and everything is stored within repository. It's mandatory to use YAML pipeline, so we need to specify everything in YAML, and we cannot use the GUI ones. So that's basically the tasks we are doing with the different stages, and you see more of this in a demo later on in the session. And we're not allowed to use release pipelines within Azure DevOps, since we cannot store that in YAML. And the pipeline itself is not stored in the repository, so we do not have any versioning of it. The last goal we had is zero-touch interfaces. So our sysadmins and everything and everybody in our project do not have any administrative rights within Azure and within Citrix Cloud. So if you have to do a change within Citrix Cloud, you have to do it via an Azure DevOps pipeline. If we dig into the first section, that's infrastructure as code with Terraform. So when we started with this project, we have to select the tool which can help us to do the infrastructure as code part with Terraform. And if you guys are doing a lot within the end user computing world, you also see a lot going on there with ARM and Bicep. But we decided to use the HashiCorp Terraform tool. And for us, yeah, it was a pro that Terraform supports a multiple platform. So as I've told you within our project context, I need to deploy infrastructure on Azure and vSphere at the first MVP. So if we look to Microsoft ARM and Bicep, is that both are Azure only. And if you look to ARM itself, it's complex. It's very complex. So that's, I think, why Microsoft created Bicep, and Bicep is just an ARM template generator. So yeah, you can just specify some language which generates a complex ARM template. Both are a declarative approach, but you can use both for redeployment. If you look to the HashiCorp Terraform, and you can also see this in the demo later, there's a plan section, so you can do a what-if scenario. So HashiCorp Terraform will tell you upfront what it will do, if it will create new resources, or it will destroy, or it will change, and what it's going to change, and if you want to allow it. So for us, the other hand is that if we're using HashiCorp Terraform, our developer guys only need to learn one language to manage all those different platforms, even for AWS in the future. So if you're trying to do it, for example, with Microsoft Bicep to do the Azure part, and then combine it with, for example, VMware Power CLI, then you need to dig into the both tools. So for us, it was a pro that our developers need to learn one declarative language, which is Terraform. So if you look to Terraform and you go to the Terraform provider list, it's called the Terraform registry. You can just go to the website and you will see there they're supporting a lot of providers. And that's basically a platform where you can deploy resources with Terraform. So you see here the most common, which is AWS, Azure, GCP, and that are also the main 3 public cloud platforms which Citrix supported. But hey, if you want to deploy things on Alibaba Cloud, maybe Oracle Cloud Infrastructure, or maybe manage your Azure Active Directory with Terraform, it's possible. And it's also possible to manage your environment with Terraform on VMware vSphere, and that's the one we needed. If you go to a particular provider, so this is an example from their website for Azure Remote Manager, there is a very good documentation about how to use those providers. And on the left-hand side, you will see all the types of services which you can deploy with Terraform, and that's a lot. So if you want, for example, want to deploy a CDN, it's possible, or a Cosmos DB, DNS, etc., etc. If you just look into the WVD space, there is also a section called Desktop Virtualization, and this is that simple how to create a host pool with Terraform on Azure. just, I think these are a line of 15 of code, and then you're done. Then you have a virtual desktop host pool on Azure. So if you just look to the language used by Terraform is called HashiCorp language. And it's very simple. And this is an example how to deploy a virtual machine on Azure. So the first thing you will describe is what you want to do. In this example, I want to deploy a resource, an Azure Remote Manager Windows virtual machine, and I just give it a label. So for example, my first Azure virtual machine. And then it's just like a form. You can just fill in a name, and this is my first Azure VM. I can also specify the SKU, like by the size. It's like standard F2. The admin username, the admin password, and I can map a network interface card, which I can specify also like resource Azure RM network interface card. I can also specify the source image reference. So this is a marketplace image. So my VM is deployed with the Microsoft Windows Server 2016 data center with the latest version. So if I deploy this with Terraform, the most recent marketplace image is used with the latest patches. And I can also specify some properties of my operating system disk. So this is standard LRS, so which is HHD. And the caching in this case is read-write. So on the other hand, you can also link things. Like this is a very simple example how to specify a virtual machine, but Terraform also has a lot of functions, but the most commonly used is just linking things. So for example, on the right-hand side, I specified an Azure Remote Manager resource group with the label main. And I give it a name like a resource group West Europe, my first Azure Terraform deployment, and the location is West Europe. So from my virtual machine, I just can simply link the resource group name to the resource group name object of the virtual machine. So just by specifying the resource type, label, and then the output. And if you see the documentation about Terraform, it will describe which objects it will return. So for example, if I change my code with the location to East US, I just have to adjust this piece of code, and then my virtual machine will be automatically recreated in the East US region, and everything which is linked to that particular resource group. If you look to Terraform, there are a lot of command line options, but these are the four most common used. So the first one is Terraform init, and as the name specified, you can just download Terraform, for example, from terraform.io, put it on your Windows, Mac, or Linux machine, and it's even in the Azure CLI. You can start writing your Terraform files, which is actually a TF file, and then just type in Terraform init, and Terraform will initialize your code. So it will check if it's okay. It will try to connect to your provider. So if you specified a connection, for example, to Azure, it will check if it can connect and download that provider for you. Then you can specify Terraform plan. That's not mandatory, it's optional, but when you do Terraform plan, it will connect to your resource providers and your code, and it will show you the differences between both, and will tell you like, hey, I am creating 4 new virtual machines, destroying 3 and changing 5. And that Terraform plan can output a TF plan file, which is actually the output and the what if scenario. And you can apply the TF plan file, for example. So you're sure that the plan you approved is applied to your resources, but it's not mandatory to specify the TF plan file. If you just specify the Terraform apply, Terraform will ask you like, are you really sure? Then you press yes, and then it will just apply a configuration to your provider, so for example to Azure. And it's also good to know is that Terraform, it's a desired state configuration. So for example, if I've specified in my example here the standard F2 virtual machine, and there is an administrator which logs into Azure and changes the F2 to a D4, for example, Terraform will tell you like, hey, there is a difference. I will do a rollback to the F2 virtual machine. And if you're done with everything, you can just do a Terraform destroy, and then it will destroy all the resources which you deploy to Terraform. So there are some common files to recognize. We've got a TF file, so that's the Terraform file itself, where you specify the Terraform code, the TF vars file, where you specify all the values of your variables, the TF plan file, and yeah, this is a TF state file. This is a file which Terraform is using to keep an eye and track on the real world and your code. So it's constantly using the TF state file to tell you about the differences and all that kind of things. So Stephanie, if you want to start the first demo, I think you have to do it. Welcome to my Terraform demo, and as you can see here, I've specified on a repository, and I added it with Visual Studio Code, how to deploy the Citrix cloud connectors on Azure. So we got a main file. In the main file, our backend is specified. So in this example, it's Azure, and it can also be, for example, AWS or vSphere. We will deploy an availability set, which will where the virtual machines will reside. We will deploy a key vault self-signed certificates, and these self-signed certificates are placed in a key vault which already exists on Azure, and this self-signed certificate is used to connect with Win10MU HTTPS to deploy software on the deployed VMs on Azure. Network interfaces, and I will show you later on in this demo. I added a count here. So for example, how many network interfaces are deployed. So if I specify three times this network interface is deployed on Azure. A resource group where all the resources are deployed. The virtual machine itself, which SKU version, which OS disk, which OS profile, the time zone, the Win10MU protocol with the certificate, and yeah, some tags. I will also import some existing data. For example, I cannot redeploy my virtual network with its subnet since it's deployed manually as a path with a peering. And my key vault, I don't want to redeploy my key vault. I have some outputs, so when the Terraform is finished, I will get the VM name and the IP addresses, which is created by Terraform. The variables from TF, and I declare all the Terraform variables in here. And I got my variable file, it's TF vars. And it's a little bit funny. I will show you on the pipeline deployment is that the you can specify a Terraform workspace. So we specified multiple workspaces, and when you deploy it in a workplace, Terraform will use the mapping variables for that. So for example, if I specify UAT, then the environment letter everywhere will be A. Or the cloud connector amount for UAT will be 2. And for development, for example, 1. And if I specify the Terraform workspace UAT, a D2SV4 is used for the deployment on Azure. Also the standard SSD, and when we do production, the premium is used. And the same is for the start of the host number. And we can specify all the variables in the Terraform vars file. So let's go to Azure DevOps. I've created a multi-stage pipeline here. It's called a Born CI/CD demo. And if you see the last pipeline, I deployed it to the development environment. It's a multi-stage pipeline. So the first pipeline is to do the Terraform plan. And the Terraform plan is like a what-if scenario. So when Terraform plan runs, it will give you an overview of what resources will be created, changed, or destroyed. This Terraform plan file is added as an artifact to the pipeline. So when the next stage, the deploy Citrix backend, which has a dependency of a check, which is actually an approve. So when the approver approves the changes, which is published in the TF plan artifact, then the actual deployment will start based on the TF plan, which is copied back from the artifacts. So since we've done this in development, I will now set up a UAT run. So I will do it from the master branch. I will do it for UAT. This is where my TF state files are saved. So this is actually a storage account in my Azure subscription, and we will press run. The pipeline will start running, and I will fast forward it to the actual point that the Terraform plan has run. So the Terraform plan has run, and you see here that it will create a lot of resources. A to add, a 0 to change, and it will add 2 cloud connectors with an A name. I received an email that I need to approve the stage to deploy the actual infrastructure in UAT. So when I go back to the pipeline, you see that the second stage is waiting, and I can put review. I'm the approver, like good job, and deploy stuff, and then we press approve. Now the deployment pipeline will start, and I will fast forward to the point that it will actually is starting to deploy resources. And as you can see now, Terraform is creating resources on Azure. I will fast forward to the point that the resources are created, but when you see here is refresh, there are no resources yet for the cloud connectors, and I will fast forward to the point that the actual deployment is finished. So as you can see now, all the resources as described in Terraform are created on Azure. The pipeline is still grabbing the Terraform state file, but if we go to Azure, we see that the resource group West Europe Infrastructure Citrix Cloud Connector UAT is added with their resources in it. So now we can test this for the user acceptance testing. And if we want to deploy it, for example, to production, we can run the same pipeline and say like, hey, put it to production green, and then press run. And then it will do exactly the same for green. So thank you for watching my demo.
Yeah.
Okay.
Hey, Pat, just one short question, because it was
11.
to follow. Yeah, I think the next YouTube video. Oh, it's kind of great. Hey, the DevOps pipeline. That's basically what's that exactly? Can you elaborate a bit more? Because if you never seen it before, I know when I never seen it before, I was what am I watching? That pipeline. Can you explain it a bit?
Yeah, it's some kind of way of executing things to ensure that things you described in code are successfully deployed on what you defined in code. I don't know actually how to say that correctly.
Yeah, but basically it's a Windows. It's basically a Windows or Linux machine where you give a task, right? You give a task like Terraform init. It will basically run for you Terraform init from a machine. So that gives a bit of an idea what a pipeline is.
And it just executes some task to ensure that when everything is green, then the deployment is successful.
Exactly.
Sometimes it will fail, and then it will stop deploying things.
Yeah. Good video. Thank you.
Yeah. Okay, if you look to the images code part, we are using Packer. We're building our golden images with Packer. And yeah, again, we did some comparison about what tool we want to use to manage our golden images. And on the right hand side, we see the Azure Image Builder. And yeah, again here, the same as Terraform Packer, Terraform HashiCorp Terraform. Packer is also from HashiCorp, so it supports multiple platforms. So Azure, AWS, vSphere, where Azure, in my opinion, has a giant vendor lock-in and it's Azure only. Both are images code. HashiCorp Packer, yeah, it's that simple. First time I would try to use it, I've deployed my first image within 1.5 hours. So it's very simple to do. If you read the documentation, if you watch the Azure Image Builder, it's an umbrella around Packer, and I'm thinking like, hey, how can you make things more easy than it already is? And I think you can't. So I think it's more complex than just using native Packer. So if you look to Terraform Packer, we call it an image template or a Packer template, and nowadays you have to specify it also in the HashiCorp language. So the first thing we specify is a variable. In this case, for example, an Azure AD application ID. I just give the type, for example, this is a string, and the default value. Then I specify my builder VM properties, and the builder VM is just the VM building my image, and I can reuse the variable from above by just specifying var dot and then the variable name. The third thing you need to specify is the build itself. So where to deploy, like the source is on Azure ARM with the label Azure Builder in this example, and see it like a task sequence. So two types of things are executed on the Builder VM. The first thing is a PowerShell script which just outputs a value like this is executed on the Builder VM, and the second provisioner which actually uploads a PowerShell module to the Azure Builder. So if you look at the different terminology, a Packer builder is just a machine which built the image. And if you look to the documentation, it supports a lot of platforms. So Ali Cloud, Amazon, Azure, Google. And if you just want to try it on your own laptop, you can just install VirtualBox and start trying to use Packer. Or if you already have VMware Workstation installed, you can do it over there. There are also tons of different providers I don't even have heard about. So for example, I didn't have heard about the Proxmox up front, but lately I was in contact with another CTP and it was using Proxmox. So that's just another hypervisor. And there is for us a community supported Citrix and Server hypervisor provider. So we can also use Packer with Citrix hypervisor. If we look to the next terminology, it's the provisioners, and the provisioners install and configure the software on the builder. See it like a task sequence in SCCM or MDT. So basically for Windows images, you can also deploy Linux images if you want to do Linux VDAs, for example, on Azure or on premises. But for the Windows, you can use a file provisioner, which actually uploads or downloads a file, execute a PowerShell script, command line script, or do a Windows restart. But if you want to do other things, like we're now investigating Ansible, you can also specify an Ansible playbook, and then Packer will use that Ansible playbook to configure your virtual machine. But hey, if you're more familiar with Chef or Puppets, you can just use it. So in this example, we have a builder VM, and we specify to install FSLogix, Office 365, and Teams machine-wide. So there are basically 3 steps, and we can specify by the execution some environment variables. So that environment variables are available within the builder VM. So that can basically, for example, be a password or something like that. We can also specify in which context it's executed. So for example, if you need to execute an installation script in a user context, which is domain joined, you can just specify the context at the provisioner level, and then the script is executed in that context. In our builds, we are using a lot of pipeline variables and passing it to our environment variables, so we can use some pipeline variables in our scripts. And when it's done, and in this example it's Azure, it just has an output of a managed image, an image in your shared image gallery, and when doing Citrix we need a VHD which sits on a storage account. So again and again the builder is just configuring the images, and that's the output of our build. So Stephanie, the second demo, please. So I will show you a demo about how to create an image with Packer and Azure DevOps pipelines.
All right. And beach ball, okay.
Welcome to my demo of creating a Citrix master image with Packer via Azure DevOps pipelines. So at first we want to connect our Azure repository to our local Visual Studio Code so we can edit files. When you go to Azure DevOps, you can click your project. So in my case, this is Born IT CI/CD Desktop. Within here, you can go to repositories and files, and here you can find the repository of our images code. And in this repository, all the files are stored describing our image. So for example, the Packer template or the installation script or the YAML files for the pipeline run. So if I want to edit this in Visual Studio Code, I just click clone, and clone in VS Code, open, and Visual Studio Code will ask me, I really want to open this URL. I said, okay. Select a location where the repository is stored locally, and Visual Studio Code will use Git to clone the repository to my local storage. So when I press open, I can see the files in Visual Studio. So that's very easy. Let's first start investigate the Packer templates, which are actually my image description. So within the Packer templates, I define two templates, Win10 multi-user for Azure and Windows Server 2019 for vSphere. So if you look at the files which are in the template, there are actually 3 HCL files. And HCL stands for HashiCorp language, and those files are stitched together when doing a Packer build. So let's first dig into the variables file. So in the variables file, I declared all the different variables used by the Packer template. So for example, the Azure AD application key and the Azure application ID, which is actually connected to my Azure tenant. I can mark some type of streams as sensitive by specifying sensitive is true. And when I specify the sensitive is true, the strings are not logged. So they're just replaced by stars. So the application key, for example, is not exposed in a log. If we look at the Packer template itself, you see these two sections here. One is source, which is actually the description of our Packer builder, and build. This is actually the task sequence of provisioners, which will in the end be our master image. So if we look to the source, so this is the Packer builder, I specified here Azure ARM. So if we look to the vSphere builder, I can specify, for example, here vSphere ISO to specify a vSphere build via an ISO file. As you can see here, different parameters are needed per builder type. So in this case, I need to define the cluster where my builder VM is deployed. And if I look to the Azure, I need to define the resource group where my builder VM is deployed, for example. When building a Packer image on Azure, it's very important not using a public IP. So if you enable this, a public IP will be attached to the builder VM, and yeah, you can publicly connect to Windows Remote Management. And I think you don't want that. And as you can see here, all the parameters are linked to a variable. So in this case, it's the AZ VM image offer. Those variables are specified in the PKR vars file. So for example, for this image, an Azure virtual machine size of B2MS is deployed in West Europe. If we look at the build, then we see here that it's using the builder on Azure, like the source. This is what we say seen above. Azure ARM, Windows 10 multi-user Born IT AZ. This is the label over here. When starting the build, Packer will first execute this provisioner. This is just an inline PowerShell script installing Chocolatey. Then installing 7-zip via Chocolatey, Notepad++, and build a manifest file. So we can use this, for example, as an artifact, so we know where the VHD is stored after the build. In my build, I specified the most variables for my builder in a pipeline. So for my pipelines, I specified a Packer builder vars file. And here I specified all the information used by the Packer build. So for example, my subscription ID, application ID, my builder temporary resource group name, which will be actually RG Packer build. And when the build started, put the build number as a postfix. And some variables are retrieved from the key vault. So I specify them here as retrieved from the key vault, so that I do not have to specify this in code and store this on my repository. When you look at the Packer job and we look at the Packer build, you see here that I specify during the build all the different parameters from the pipeline to a variable which we declared in Packer. So for example, the Azure AD application ID, this is the Packer variable, and this is my pipeline variable. And I also uses the PKR vars HCL file of the template as an input. So this was the file where we specified, for example, in which location the builder VM is built, or what type of marketplace image is used. This was this file. So okay, let's deploy this image to Azure. To deploy this image on Azure, we go back to Azure DevOps. And since we specified not using a public IP for a builder, it's mandatory to use a self-hosted Azure DevOps agent, since we need to have a network connection to the private IP of the builder VM. And the public Azure DevOps agents from Microsoft cannot connect to your private IP addresses. So when you go to project settings, agent pools, we see an agent pool here, which is Windows Azure NPM, which is hosting my Microsoft Partner Network subscription. And if we look to the agent, I just installed it on my WVD session host, and it's up to date and it's online. So I can use this for my pipeline run. When you want to run a pipeline, we just go to pipelines. We see here Azure Windows 10 multi-user Born IT Azure, and I simply press Run Pipeline. So these are the parameters which are specified on the YAML pipeline, and yeah, these are correct, so I can just hit Run. Now the pipeline is starting, and you see it's a multi-stage pipeline. So the first step is to actually create the image, and the second step is to copy it to the right location. And now the build is started, and I will actually go to the point that it starts creating the image. Okay, the actually build is started, as you can see here. Here is the output and the logging of the Windows 10 multi-user Azure Packer build immutable image. So as you can see here is that the temporary resource group is created called RG Packer build Windows 10 with the build number. So you can see here the build number, which is actually the build number of the run. The location is West Europe, and it's now creating temporary resources in Azure. So let's switch to Azure. So if we go to resource groups, we're seeing the same resource group here. As you can see, Packer created temporary resources in the temporary resource group. You can identify them with the prefix of PKR. The rest of the names are generated by Packer, so every run the PKR virtual machine will have a different name. So it generates a virtual machine with a corresponding network card and a key vault. And in the key vault, a certificate is stored to connect securely to Windows Remote Management. Packer will delete those resources when it's done with the Packer run. So it's still creating an image, and as you can see here, it's installed Chocolatey, and it's now installing Notepad++ and 7-zip. So it's downloading 7-zip and installing it to the image. As you can see here. So the Packer build has finished. It took about 13 minutes to build the entire image. As you can see here at the end, the Packer builder is shut down and it's deleted from Azure. At first it captured the VHD from the builder VM. So if we go back to Azure and we go back to resource groups, we can refresh here. And we are seeing here that the default the temporary resource group is removed. If we look to our images in our containers, images, I see here the most recent image, which is Windows 10 multi-user Born IT Azure, and it's the 18th build of the image. So these images can be deployed to our virtual machines in Azure with Citrix machine creation services. So we now deployed our image on Azure, and if I run the pipeline for vSphere, it will actually do the same process, only then on vSphere. Like it's now giving us the output on vSphere, and it created a VM called Packer with the Packer run number in it. And when this Packer build is done, you can use a snapshot of this image to deploy this with Citrix machine creation services, or maybe you want to make a provisioning service image of this, so you can deploy it with provisioning services.
Okay, just to wrap up, because we're nearing the end of like 8 o'clock in the Netherlands. So if you look to the images code with Packer, the big picture, the execution process is as follows. So at first we specify everything in code within our Azure repository. So our Packer template, our PowerShell scripts, which are executed on the builder VM, and our pipeline. So the first step is that we're using a self-hosted Azure DevOps agent. And the first step, what it does is installing Packer on the DevOps agent. Then it will use Packer with the specified Packer template and Packer starts to create a builder VM on the platform of choice, in this example on Azure. Then it will start to execute the provisioners on that builder VM, which is in this case on Azure, and or uploads the PowerShell scripts. So it's all executed there. You can also use Evergreen module, Chocolatey or Winget to get your resources, but you can also use, for example, Azure files to store your MSIs and executables. So when the whole task sequence is done, the last step is just to capture the image and store it for Citrix, in example, in a storage account, and we can use that with Citrix machine creation services to deploy it to our Citrix machine catalogs, and then we have a master image which is stored in code, and we can reproduce that over and over again. So for now, I want to give you a thanks for attending our session. I can imagine this is lots of information, lots of new stuff, and we just want to show you the possibilities. And I think all the 3 tools we've shown here are a session itself. So if there are any questions, please come in.
Yeah, guys, that was awesome. Thank you. Just a couple of questions, actually. There's been a couple I've answered as we've gone along, but one from me. Where would you recommend somebody looking to get into infrastructure as code, perhaps wants to start the journey that you've been on? Where would you recommend as a starting point? You know, obviously you've showed us kind of 2 or 3 different technologies here, but is there one place, you know, you would advise perhaps start there and build out from that point forward?
I think there is there are some key things to take away. I think if you start with infrastructure as code, there's a lot of tooling around. If you look at Packer or Bicep, it's all a bit equal in that way. But the real automation that hits with Azure DevOps. So I would fully first start understanding Azure DevOps to see if you can, for example, get a tool like Terraform working. And then explore further down to see your options. But I think it's key to have Azure DevOps experience. But from there, you can basically onboard any tool. I hope that this answers your question.
Yeah, no, that was awesome. Thank you. In terms of Terraform then, I mean, do you see this kind of deployment as being something, you know, obviously you explained about the use of Terraform because it was multi-platform, because you could operate against, you know, it could be AWS today, Azure tomorrow, VMware the following day. I mean, how do you see that evolving? Do you think, you know, in the future people will standardize on one platform like that, you know, and just use Terraform? Or do you think, you know, different tools will come in and out based on you know, for example, a customer's requirement?
It's just a tool to get the end goal. So I think you first have to investigate what the specific needs are and which problem you're trying to solve, and then select the right tool of the job. And I think in what we've learned now in our project is that selecting a tool which can using on a lot of platforms, it will not cost you that much of learning, since you just have to learn one tool. So for example, if you need 3 platforms and you learn 3 tools, then you have 3 times the learning curve.
And 3 times the code, because and Terraform is one language, so that makes it really easy to adopt the other ones, like Patrick said. So sure.
We've got one question here from Andre, who says, is there anything that can be used instead of an Azure DevOps pipeline? Are there any other tools out there that could be used in place of that?
Yeah, of course. You have this GitHub with the runners. It's very popular.
Jenkins.
Yeah, Jenkins. Yeah, it's also a pipeline tool. We're really lucky that we got Azure DevOps, and the whole bank is already using it in our scenario. So we also have and that's the good thing, is that teams are sharing their experience with each other. Because multiple infrastructure teams are doing the same thing, and also now selecting the same tools. So that's also very interesting to see if you speak with those product owners. There is a lot of knowledge sharing going on right now.
Where do you think you'll take this environment next? So this, obviously, the journey you've been on over the last year, 6 months to a year with this environment, what do you think it might look like in a year's time?
Yeah, we're now investigating to add Ansible in this game. Like we're doing a lot of PowerShell right now, and we're now going to the limits of PowerShell, and we're now digging into like, hey, Ansible is such easy to configure a playbook and do some kind of desired state configuration, like doing and programming a flow within PowerShell yourself. So that's what we're digging in for the next months. And if we're looking, for example, for Go AUC, we also specified our lab now within Terraform and Ansible. And we can deploy this on vSphere, so we can rebuild our lab. And since we want to do more testers, than one at each other. We're now investigating like, hey, we can just reuse the Ansible playbooks and just deploy the same resources on Azure, and then we have a lab on Azure and vSphere at the same time.
Yeah, and what also a good benefit is for that Azure DevOps is that, for example, that when you do the migration, that you're going to add users from a proof of concept to it, and then you've got the project manager to ask, hey, can you add some more users to it? And then a day later he comes back to you, hey, I forgot another one. Can you please add it to the group? Well, what you see the dev teams of the ops guys are doing now is they create a pipeline, basically accepting an input. And they give the API code to the project manager, say, okay, if you hit this API, you put this here an email address, that user will be automatically added to the group. Those things are also taking off.
Yeah, no, that sounds awesome. I know the look into the future is the $1 million question, but it's always interesting to what the sort of future plans is. That's all for the questions, guys. Thank you.
Okay, great.
You're welcome.
All right, thank you, everyone. I just had one last slide. It's just a big thank you slide. Show that one. There we go. So thank you. Thanks for being here, and thanks for your grace during the video foibles today. GoToWebinar and sharing screens and all the windows open sometimes make it a challenge.
I will share the videos, right?
Yeah.
So you can see the full HD. Yeah, great.
All right, well, thank you guys. I hope you all have a great rest of your day, and hope to see you on another CUGC event soon. Thanks, Patrick. Thanks, Rick. And thank you,
Thanks.
Jake.
Bye-bye.
Bye.
Cheers.